Travis with Boss Tables. Today we're going to be helping Dan, who is our West Coast salesman. We're going to be helping him go over some general aspects of FlashCut, and then eventually we're going to work Dan into doing installs. Life is going to be great. So everybody on the West Coast is going to see a lot more of Dan. What we got going on with FlashCut, you've got FlashCut. What FlashCut is a CNC software with CAD and CAM integrated. So CAD stands for computer aided drafting. CAM stands for computer aided manufacturing. What that essentially means is that in CAD, I'm gonna draw my parts. There's different levels of CAD. We can use about any platform of CAD that you want to use as long as you can export your part as a DXF. As you can see here on this little clipboard, this is our shop table. It's very dirty. Don't ever let your tables get this dirty, otherwise you're gonna have problems. Good thing for us, we have all the parts to fix this, so apparently CAD doesn't really have to keep very good maintenance on it. I can draw machines like this in CAD. These different machines that we've built over the years and vice versa, we draw these in SolidWorks. You can use like Autodesk, you can use Fusion 360, you can use SolidWorks. You then draw it as a 3D model, and then you can export individual parts into FlashCut to cut them out. You can import the parts directly into CAD if you wish to make a subtle change, or you want to change the size of a bolt hole, you want to lengthen a slot. FlashCut makes it really easy to import and edit the drawing itself. If you want to bring it into CAM, the reason why you'd want to bring it into CAM is because your part is already created, it's already the size that you want. CAM is computer aided manufacturing. It's where we're going to nest everything, and then we're going to physically cut it out in CNC. I find FlashCut, I double click on it, it opens up. If you guys had a shutdown that was unscheduled, it will ask you to recover those documents. We're not going to do that right now, but it is a nice little feature that is implemented in the new version of FlashCut. I hit agree to my license, safety first, trained operators, you know, stay out of the way, machine may start automatically, you know, all that kind of stuff. So these machines are inherently dangerous, they're safe if used correctly. We've got hundreds and hundreds and hundreds of them out there. Guys use them every day, but it's still a machine. It does what it's told. What my little caveat with that is that it does what it's told. Generally, if there's a problem, kind of more or less user operator error, but we'll go over that here in a second, and we'll actually produce some errors on this machine. That's why we're on this old machine, so we can actually kind of beat on it and see what's gonna happen, right? I bring it open into CAD. I then can select DXF. I select DXF, I hit browse. I need to find my file. The files system that we use, you can email them to yourself. You can bring it in on a flash jump drive. You can use a file share system like OneDrive potentially. We use Ignite, and we have a service system for a Z drive. So we have all of our machines backed up into the cloud, into our server, locally, and then we have a external hard drive that we save everything into too in case we lose it in the cloud. And then we also have it in Ignite, which is another cloud software, because we have a ton of money in engineering to design all of these machines. So then when you guys call as a potential customer and you go, I want an 8x24, I want a 10x30, I want this. Perfect, we've already done it. So then there's not an engineering fee that has to occur every time. It keeps this a lot more seamless, keeps our files organized. So this is our Z drive server system thing. I'm not 100%, I'm not a network guy, but basically all of our files go from Ross or myself or anybody that draws the files. We then edit the files or create the files. We sort them into different folders, and then Caden, Nick or Ted or whoever is on the machine itself can then find those files and not have to walk back and forth with a jump drive to get those files transferred between computer to computer. It goes up into the cloud, comes back down onto this platform, and then we can physically, you know, cut it out, right? If I choose a file, boom, I can choose multiple files. Well, I can choose one if I'm importing a DXF to edit it, sorry. So if I open that, boom, your little progress bar here, it's got this guy right here. I have one layer, you can draw it on different layers. Layers, what they are is essentially, you've got white, black, and green for like vinyl printing. Vinyl printing is an easy way to describe layers. You could use different layers to show different dimensions, different features, or different tool paths, or different colors. For vinyl printing, you would use different layers for red, green, blue, so you can vinyl print inside the lines, vice versa. For us, Generally, everything's drawn on layer 0. You can draw it on whatever layer you want. It'll import it automatically. You could then create a mark or a scribe layer, and that will then automatically scribe that layer automatically because it's named a scribe. And if you wanted, whoever is supplying or you exporting your DXF could also export the DWG or the dimensions of it as well. And you can choose, if it's in this imported layers, you could uncheck that and get rid of all of the layers that you don't want. For us, we simply draw it in layer 0. We have blueprints and everything else in different files so they can be opened up in a PDF viewer to keep things super simple. Much the same, we have a kiosk the same as this by our press brake that has PDF files so that way we can see where the bends are supposed to be, the degrees are supposed to be, and it helps everything stay a little bit more seamless. And it also keeps, you know, we still do print documents out because it is nice to have the old analog paper, but it keeps a bunch of papers from flying around the shop when the wind is blowing through this place, because years and years ago, back before we had work kiosks and all the stuff, there were papers everywhere, and when the wind would pick up, there'd be papers blowing through the shop, and we'd be losing blueprints, we'd be losing this, and we'd have to go reprint them, and then we went, basically tried to make everything as digital as we could. It's a good process, it makes it more repeatable, and then if somebody loses or breaks or scratches or bends a part wrong, they can just come back on here, open it back up, because it's already on the server, or your file share system, cut it out, bend it again, you're ready to go. It makes everything a lot more seamless, makes your potential people a lot more autonomous, so that way they're not relying on, let's say, the engineer, who Ross is our head engineer, he's gonna be overwhelmed with people going, hey, can I get a blueprint? Hey, can I get this? Can I get this simple file? It's gonna take more time away from him, and or if you're the owner of the company and you've got, you know, you're trying to quote jobs, you're trying to find more work, you're on the phone with a client and you're printing blueprints, it's over and over and over again for the 6th time, it's kind of annoying. So a good CAD system is a really good asset to your company, right? FlashCut does have CAD. Does it work? Absolutely, it works just fine. The thing is that I would never draw an entire machine or an entire assembly on FlashCut. What FlashCut works really good for is shop floor programming. I need a gusset, I need a motor bracket, I need a tabletop, art. Also art works really, really well on this guy, but flashback a couple of days, I did a quick video on a bracket I made for my pergola. Super simple, super quick, didn't have to open up SolidWorks, didn't have to do a bunch of messing around, just drew it real quick on this guy. It works really well for that. Or if you wanna edit a part, so like this is a large end cap for our new laser. Here's your dust extraction port. Let's say I wanted to take these holes and make them a little bit bigger and shove a 3/8 by 16 bolt through it, or a 1/2 by 20. I can then just oversize those holes and then recut the thing out if I so choose, right? So it imports it in. Once again, we're in CAD, right? I can select the check mark, boom, my part turns gray. If my part is not gray on FlashCut, generally it means that there is an issue. There is an open contour. I will come in here and I'll zoom in and I'm gonna take this guy and I'm gonna explode it, which means I'm gonna take this entire outside feature, or I'm gonna ungroup it. So I ungroup it, and then now I've got individual part features right here. So if I click on this line, so I've got this fillet, I got this line, I got this fillet, and it comes down into here. If I hit delete, that guy's mad, right? And my little holes now are gray. What that means is that FlashCut doesn't really know what's going on. It's trying to do the best that it can. A prime example would be, as I import a part, I have a line. So my line, I'm gonna zoom in. Like I'm splitting the hair of the atom right here, right? So I created a line. I zoom out and I'm like, what, you know, what's wrong here? Why isn't this working, right? Because as I look at it, I go, everything's fine. This is a CAD software. It's not intuitive. It doesn't just go, oh, this is what they want, right? We're just gonna help them. Now, it will help you, but you have to tell it to help you, right? It's a machine, it does what it's told. So if I wanted to check for open contours, what I can then do is go to my fixed drawing tool, which is a great asset that FlashCut has. I go fixed drawing, boom, click that, and it says, you know, the overlap tolerance you have is quite large, right? The joint tolerance is 0.88, which is pretty large. Let's say I go 0.125, and I hit search for issues, green, right there. It shows where it is. And then I go, okay, that's cool, fix all. Boom, fixes that. We have another video that I made years and years ago about a friend of mine who wanted to cut out a sign for his family. And I was like, yeah, man, that's cool. I'll cut your sign out if you draw it, because I don't want to draw it. I don't have the time, whatever. Beautiful drawing, great looking sign. Problem is there was about 1,000 broken contours in it. And I'm like, man, this would take a long time if I didn't have FlashCut. I hit fix all, boom, fix that drawing, away I go. Save me hours and hours and hours of time. It is a great asset. CAD is computer aided drafting. This is not where I'm gonna create a nest and create a bunch of toolpaths. This is CAD, computer aided drafting. This is where I'm gonna draw my part, or I'm gonna edit my part, and then once I'm finished with that, I'm gonna send it into CAM. And then from there in CAM, I'm gonna create a toolpath. So let's, for example, I hit the arrow buttons, it shoves it over. I can see that it already created a little red line, so it already created a toolpath. Look at that, we're good to go. It's creating toolpaths, Smart Hole 360s, automatically implemented, and it's doing the inner profiles the same as the outer profiles that are larger than a certain diameter of hole. Boom, 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 right? I can see right here that it's mad because this is my job and this is my part. My part is way off of my job. So I'm just gonna run through this real quick and we'll go over this at a later date as well. First thing I would do is, if I was to cut this one part out, project settings, PowerMax Sync. If I wanted to cut this out with oxy-fuel, I choose oxy-fuel right here, right? PowerMax Sync is what we're gonna use. If you have a Max Pro, it'll say Max Pro. If you have an XPR, it'll say XPR. No big deal. I go into my job settings, and then this is where I would choose the thickness of steel. This guy is cut, I believe, at 1/4 inch, so I would go and choose 1/4 inch mild steel right here. And then the width of my job is now, let's say I go 60 by 120. For a 5x10, right? So I can see that my length and my width, and this is all set up on where your controller is. 1/4 inch, set my job, check mark. If I don't hit the check mark, that's not gonna save. Now I got my 0, 0 right here, right? I'm in CAM, so I can then take and nest this, right? If I change my 0, 0 and I bring it over there, it changes the 0, 0 of my job. If I drag this guy over here, and I'm gonna take this guy, and I'm gonna drag him real close to my 0, 0. When I shove it over into CNC, if I drive my machine around, right? So when I drive my machine around, I'll zero it in a certain corner. When I hit set 0, X, and Y, now I can see that my machine is right here. When I drive this guy, I can see that I'm right here, right? Now this is a good example. I can see, well, hey, I'm trying to drive this way. My part is all the way over there, but my machine doesn't go over there, right? So that means I set the job up backwards on my material for my length and width. I need to re-nest it, vice versa. So good little problem that I created to show you, what you'll be dealing with. A common call that we get from people is they go, when I send stuff out of CAM into CNC, it throws an error and it says that it's outside of the machine envelope, will not fit. Well, the problem with that is that your part doesn't fit. One thing that I also forgot, good thing as well, because this is a learning experience for everybody, including me today, apparently, I need to home my machine initially when it starts. When you home your machine, it sets the motors and the software to know exactly where it is. It's a machine, it doesn't know what it does. So picture this, it wakes up every morning, it doesn't know where it is, what it's doing, how it's gonna do it, and even where it woke up at, right? So first thing I need to do is I need to tell it where it is, so I need to set home, so that way it knows where it is in life, and then it doesn't know what it's supposed to do, so then I need to tell it the material, and I need to tell it what consumables we're gonna run, and then I need to tell it what we're gonna do, so I need to give it a part, and then I need to tell it how to do it. I need a tool path, and then I need to tell it to actually do it. It's a machine, it does what it's told. Once you get all these steps down, and it's super simple, I have a part, I home my machine, I zero my machine out where my work is, give it the work out of CAM, and then I tell it to do it. And if all is good, it's gonna cut my parts out, and then we're gonna ride off in the sunset and everybody's gonna retire rich, right? That's the idea. Coming out of CAM, I just started this machine up. I will then hit home, home all. And what that does is it touches off your Z, X, and Y axis. It then travels back, touches off the switches, and it sets the machine coordinates, right? Okay, perfect, right? We're good. So now I won't correct this issue just yet. And I'm gonna pretend my material is right here, right? So when I go set 0, X, and Y, it gives me this. The toolpath goes outside of the machine envelope as follows. It's mad. So hit okay, right? I can see my blue right here. Here's my machine right here. Here's my part. No bueno. Not gonna happen. So how do I fix that? I go into CAM. I can just take this guy, flip it around, and then drag him back down in there. But now you can see that my job is here. Well, I shove it over into CAM, proceed without remnants. We're not worried about remnants right now. I can see, hey, this looks pretty good, but now this is not good. I can run this part. As long as this fits on my material, I could run this. This is a representation of your G code. This is your machine coordinates, and this is your work piece. Now, I told it where the work piece is, but that doesn't mean that it's actually there. I could run this, and it would run the part just fine if I had material on the table. But what I'll do is I'll go back to CAM, and just for example, I can either click on my workpiece, or I can click up here. I will then change this to 60 by 120. Select my check mark, and then I'm gonna drag this guy back in over, right? So then now I've got this, so when I shove it over into CAM, it's gonna rewrite the G code, reset the 0 offset, all the jazz. Proceed without remnants update. We're not worried about remnants right now, right? So now you can see life is pretty good. If I drive my machine around, I can then see everything on my part. No big deal. I can hit run. As long as I chose everything correct, it's gonna cut that part out. It's gonna do what it's supposed to do. No big deal. Let's go back, choose a smaller part, and let's make a drastic mistake so that way I can show you what's going on, right? Let's go CAM, and I'll hit File, New 2D part, Document 1. I'll then import a DXF. Oh, sorry, I'm in CAD. I don't need to be in CAD because I already have my parts drawn. I'll go Import DXF in CAM. I hit Browse. I'll hit, let's find something small. These are all big parts here. Tables, laser, tables, access hole ring. It imports it in. I got one layer 0. I can see that my parts are gonna get cut. All the holes are gonna get cut. So I got my 0 point way over here. See that little crosshair? I come over here, my part's way over here. I'm like, all right, cool. Send it over into CNC. I'm here, I can see my little check mark. This is me on the screen, driving around way over here in the middle of my table. My part is way down there, and there's my 0. I'm like, well, it's not really what we're looking for. It's not right. So I can go CAM, I can then drag this part if I want, all the way over here, and then boom, and then shove it over into CNC, and then there we go. Now when I drive my machine around, it's gonna be in the correct 0 location. Right? This is where I initially zeroed it. Let's say I'm gonna line it up on this little plate right here, which is a piece of scrap metal. Everybody has tons of scrap metal laying around their shop. I put it right there. I hit set 0, X, and Y. Now my part snaps to this part, to this area on the plate. I can then drive it around, right? And I can see that it's gonna fit on that material, right? One thing that we flossed over, I'll go back, and I'm gonna make another mistake. This is a really common mistake that a lot of guys do. I tell it size of my material. I told it it was 1/4 inch initially. This is not 1/4 inch, this is 1/8 inch. I tell it 1/8 inch, which is good. It helps a lot. It helps a ton. It helps more than people know. I select the check mark. Automatically updates the toolpath. It automatically updates the toolpath off of your consumable settings. Right now, this says 65 amp cartridge in it, right? So, that's okay. I can cut 1/8 inch. I can do up to 1/2 inch to 65, and it'll do a really nice job. Leave it at 65. Hit the check mark, throw it into CNC, proceed without remnants. Drive it up. I then come over here and I'll grab my consumables, right? So this guy, 65 amp. You guys will learn when your consumables are getting worn, right? So I don't know what the status of this guy is, but we're gonna tell it it's not 65 and we're gonna make a mistake so that way everybody can see what happens, right? The new models are sinks. I pull off the consumables. That is gonna have an air on it. My plasma cutter is gonna have an air on it. It have a little lightning bolt on the front. right? No big deal. I can reset that error by that. There's a switch on the side of your torch, super simple. The old Gen 4s, I believe, you had to go walk over and power cycle the machines. You don't have to do that with this. You can just simply flip this switch. You're good to go. If I cut this out with 65, it'll work. But let's say I tell it that it's actually 85 amps. I hit the check mark, I send it back over. The machine doesn't know any different. It's still gonna do what it's told, right? So when I hit the run button, it's gonna go over. Let me re-zero my job, set 0, X, and Y. So if I'm on marker and I select and set my 0, X, and Y, I can then position everything off of that location, but I need to have Power Max selected when I hit set 0, X, and Y, and then I'll hit reset G code. Now everything's gonna fit like it should. Apparently we're really good at making mistakes today, which is what we're all about. Set 0, X, and Y. Now I can drive my machine around. I have Power Max Sync selected. I must have fat fingered and selected marker. This is a potential thing where you select marker. Why would you want to do that? I got my plasma, I got my marker. I can then take and grab my marker by hand and zero it right into an exact position and then hit set 0 with that. So select marker and then set 0 with my marker and then hit run, and it will automatically change tools, automatically set the offset and keep running. It's a valuable feature, but for all practical training purposes, it's kind of confusing. If you choose this fab head, which is Power Max Sync, and I hit set 0, X, and Y, it's gonna set that offset on that fab head, because that's what I have chosen. Oxy-fuel, we have a dual mount for plasma and oxy-fuel, so you park one, park the other. That offset is 0, but the marker offset, which is this guy right here, right? That guy is offset by about 2 3/8 of an inch by 3/4 of an inch, right? So anyways, I selected 85 amps, even though I have a 65 amp tip in the machine. I'm gonna select run, curve cross, sure. It's gonna touch off, and it's gonna cut this hole just fine, even though I chose the wrong consumables, right? This is a common thing where guys go, it cuts the holes, but then when it goes to cut the ring, it doesn't, it rides too high, it scars the material, it cuts terrible, or it dives down into the material, right? And all of that is commanded by your digital torch height, which is this voltage right here. So as the machine is running around and cutting, what we're measuring is the electrode to the bottom of the plate, the arc voltage, and we're implementing a change in height off of that voltage. We'll let it cut this last hole, and then we'll see how it does when it cuts this inside circle, right? So you can see how it's riding really high. It does it. I hit the stop button. I got a large curve. It's beveled, right? Now, why is it beveled? It has 65 amp consumables in it. That plasma cutter is automatically set to 65 when it's a sync. So if I put 45s in it and then I reset my plasma unit, it knows it's 45s. But this thinks it's 85. This guy thinks it has 85 amp tips in it. The power unit thinks it has 45. Clash. So let's take it a step further. That has a bad kerf to it because I told it that it's 85 on the CNC, but it has 65 in the power unit. So if I come in and I swap this out, let's just say I grab a 45, use 45, even better, throw that guy on. I reset my torch, resets the power unit. Well, now I got things really going on here because now I've got a 85 amp setting in here. So I can see that this is set to 85 amp cartridge. And then in CNC, I just change that to a 45, right? So let's see what's gonna happen. Not gonna like it, but it'll do it. It does what it's told. It's a machine, right? So I hit run, right? So you can see how it's running really, really fast. Now, did it do it? Yeah, it did it. But cut quality is gonna be terrible. Well, let me rephrase that. It did it, but it didn't do it really at all. I can see that this guy is welded to the slats, and I can see that it's cut terrible, right? This is a prime example of common things that happen when guys, like, we'll come there, we'll train, guys are like, I got it. And then they do, but they don't. And then we do things like this. This is all learning process stuff. one thing to really keep in mind, if you do fine cut and you do 45, which is what I have on here, you can see that they're different, right? They're vastly different. We've also had some guys, they're like, well, drag tips look eerily similar to fine cut. I mean, no, don't. It's bad. Don't do it. These are both 45 amp consumables. They're both 45, but the settings are different in FlashCut. This runs about 90 volts, arc volts to set the height. This runs about 120. So if you have this one in, but this one selected in the program, your digital torch height's gonna be all messed up. One of two things is gonna happen, whether you have it selected vice versa. It's either gonna drag on the materials, which is really hard on consumables, or it's gonna ride really, really high. Because at the same 45 amp output on this, it's reading about 90 arc volts. This is reading about 120. So when I have this set at 120 on my CNC, but I have this at 45 amp in the plasma cutter, the CNC is gonna go, all right, cool. You're looking for 125 volts. CNC is gonna say, all right, cool, get there. So it's gonna raise up, and then it's just gonna start scarring the material ridiculously high and not cutting through. Kind of the same thing, exactly what we just did with choosing a 45 amp with an 85 amp head, right? So that's the big takeaway with this, is that, you know, the machine itself is a machine, right? As long as we have good things coming in, normally our output's gonna be pretty good. Garbage in, garbage out. You know, my body's a temple, that kind of thing. Your machine is a temple. Keep it clean. Don't do like us. Clean your slats up. Don't let them grow together like they have some sort of melanoma cancer thing going on, right? Keep your bearings clean. Machine will last a long time. Your bearings are gonna last a long time. Don't let it look like this. I suppose maybe we have this as an example to make sure that people know what a dirty machine looks like. Because if you've ever sent us a picture of a machine looks like this, and you go, I got issues, we're gonna say, probably. Anyways, but we have the bearings on hand to fix our own stuff, so apparently we can be lazy. And I do love selling bearings, no problem. But yeah, that's a big takeaway. If you guys have any questions, you know, you can feel free to give us a call.